Hello everyone, welcome to this tutorial on the PySpark SQL lag function. In this video, we'll explore how to use the lag function to access data from previous rows within a dataset. This function is incredibly useful when you're analyzing trends, calculating changes, or comparing current values with past ones. We'll go through practical examples to show how you can apply the lag function in your own data analysis. Let's dive in and learn how it works. Introduction to the lag function. The lag function in PySpark is a powerful tool that allows you to access data from a previous row within a window, making it easier to compare values across rows. This function works by looking at a specified number of rows before the current row based on the order defined within the window. It is especially useful in scenarios where you need to calculate differences or detect changes between consecutive rows, such as tracking trends in financial data, comparing sales figures from one period to the next, or calculating percentage changes over time. For instance, if you have time series data, the lag function helps you analyze how a particular metric has changed compared to the previous entry. By accessing the data from earlier rows, you can create insights such as whether a value has increased, decreased, or remained the same, and use these insights to detect patterns or anomalies in the data. This function is commonly used for tasks like calculating the difference between current and previous sales numbers, determining changes in customer behavior, or tracking stock prices over time. With the lag function, comparing consecutive rows in your data becomes straightforward, making it an essential tool for data analysis where historical comparisons are needed. Basic syntax. The basic syntax for using the lag function in PySpark involves defining a window specification and applying the lag function over that window. The window is created using window.partitionB and window.orderB, which determine how the rows are grouped and ordered for comparison. The partitionB clause divides the data into groups based on a specified column, ensuring that the lag function works within each group independently. For example, if you are analyzing sales data, you might partition the data by region or product category to calculate comparisons within each group. The order by clause specifies how the rows should be ordered within each partition, usually by time, date, or a numeric column like sales or price. Once the window is defined, the lag function is applied using with column, creating a new column that contains the value from the previous row. The lag function retrieves the value from a specified number of rows before the current row, known as the offset. By default, the offset is 1, meaning it looks at the immediately preceding row, but you can adjust the offset to access values from further back. Why use lag? The lag function is essential when you need to compare the current row with previous rows, especially in situations where understanding changes over time is critical. One of the most common use cases is calculating period over period changes, such as comparing month over month or year over year sales figures. By accessing the value from a previous row, the lag function allows you to easily compute the difference or percentage change between consecutive time periods, helping to identify growth trends or declines. Additionally, lag is widely used in time series analysis to detect patterns and trends. For example, it can help track the movement of stock prices, monitor changes in sensor data, or analyze customer behavior over time. By looking at historical values, you can assess how metrics have shifted and use this insight to predict future behavior or detect anomalies. Practical examples. 1. Accessing the previous row. In this example, we are using the lag function in PySpark to access the salary from the previous row and create a comparison between the current and previous rows. The DataFrame DF contains two columns, employee underscore name and salary, representing employees and their respective salaries. Our goal is to use the lag function to create a new column that contains the salary of the preceding row for each employee. First, we define a window specification using window.orderBySalary. This orders the rows in ascending order based on the salary, ensuring that the employees are listed from the lowest to the highest salary. The ordering is crucial because the lag function retrieves the value from the preceding row, and this order defines which row is considered previous. Next, we apply the lag function over the window specification with an offset of 1. This means that for each row, the function will retrieve the value of the salary from the immediately preceding row. The result is stored in a new column called previous underscore salary. When we display the result using the show method, we can see that the first row for Bob with the lowest salary of 4,500 has no previous salary, so the value is null. For David, the previous salary is 4,500 from Bob, and so on. The function allows us to easily compare each employee's salary to that of the employee with the next lowest salary. This example illustrates how the lag function can be used to create comparisons between consecutive rows in a dataset. It is particularly useful in scenarios where you need to analyze changes or differences between rows, such as tracking salary trends or detecting patterns in sequential data. 2. Using lag with the partition. In this example, we are using the lag function in PySpark to access the salary from the previous row within each department. The DataFrame df underscore depth contains three columns: employee underscore name, department, and salary, representing employees, their departments, and their salaries. The objective is to use the lag function to create a new column that contains the salary from the previous employee within the same department, allowing us to compare salaries within each department. We start by defining a window specification using window.partitionByDepartment.orderBySalary. The partition by function groups the data by department, meaning that the lag function will operate separately within each department. The order by salary clause ensures that within each department the employees are ordered by their salary in ascending order, which is necessary for determining the previous row based on salary. Next, we apply the lag function with an offset of 1, meaning that it will retrieve the salary from the immediately preceding row within each department. The result is stored in a new column called previous underscore salary. When we display the result using the show method, we can see that for each department, the first employee, the one with the lowest salary, has a null value in the previous underscore salary column because there is no earlier row to reference. For example, in the HR department, David has a salary of 5,500 and Alice has a salary of 5,000. So David has Alice's salary as the previous underscore salary. In the finance department, Bob has no previous salary, but Charlie has Bob's salary of 4,500 listed as the previous one. This example demonstrates how the lag function can be used within partitions, in this case departments, to compare each row to its previous one, which is particularly useful for tracking changes or trends within groups. 3. Calculating period over period change. In this example, we are using the lag function in PySpark to calculate the difference in salary between consecutive rows. The DataFrame DF contains two columns: employee underscore name and salary, representing employees and their respective salaries. The objective is to calculate the salary change for each employee by comparing their salary with the salary of the previous employee. We begin by defining a window specification using window.orderBySalary. This orders the rows by salary in ascending order, ensuring that the lag function can compare each row with the previous one based on salary. Next, we apply the lag function with an offset of 1, which retrieves the salary from the previous row. This is stored in a new column called previous underscore salary. Then we use the with column function again to create another column called salary underscore change, which calculates the difference between the current salary and the previous salary. We do this by subtracting the previous underscore salary column from the salary column using call salary call previous underscore salary. When we display the result using the show method, we can see that the first row Bob with the lowest salary of 4,500 has a null value in the previous underscore salary column because there is no prior row to reference. For subsequent rows, the salary difference is calculated based on the difference between the current and previous salaries. For example, Charlie has a salary of 6,000 and the difference from Bob's salary of 4,500 is 1,500, which is shown in the salary underscore change column. This example demonstrates how to use lag to access previous rows and calculate differences between consecutive values, which is useful for tracking changes over time or identifying trends in data. 4. Using lag with different offsets. In this example, we are using the lag function in PySpark to access the salary from two rows before the current row. The DataFrame DF contains two columns, employee underscore name and salary, representing employees and their respective salaries. Our goal is to create a new column that shows the salary from two rows prior for each employee, allowing us to look back further in the data. We start by defining a window specification using window.order salary. This orders the employees by their salary in ascending order, which is necessary for determining the relative position of each row in the sequence. Next, we apply the lag function with an offset of 2, meaning that it retrieves the salary from two rows before the current row. The result is stored in a new column called salary underscore 2 underscore prior. When we display the result using the show method, we can see that the first two rows do not have any values in the salary underscore 2 underscore prior column because there aren't enough preceding rows for the function to access, since these rows are the first and second in the ordered list. Starting from the third row, the function successfully retrieves the salary from two rows before. For example, Charlie with a salary of 6,000 has Bob's salary of 4,500 as the value for salary underscore 2 underscore prior. This example demonstrates how to use the lag function with a custom offset to look back multiple rows in the dataset, which is useful when you need to analyze historical data over a longer range or perform comparisons that span more than one row. 5. Handling nulls with lag. In this example, we are using the lag function in PySpark to retrieve the salary from the previous row and provide a default value of 0 when no previous row exists. The data frame DF contains two columns, employee underscore name and salary, representing employees and their respective salaries. Our goal is to create a new column that retrieves the previous row's salary, but instead of returning null for the first row which has no previous row, we will return a default value of 0. We start by defining a window specification using window.order by salary. This orders the employees by their salary in ascending order, ensuring that the rows are processed in the correct sequence. Next, we apply the lag function with an offset of 1, which retrieves the salary from the immediately preceding row. In addition, we pass a third argument 0 to the lag function, which specifies the default value to use when no previous row is available. This default value of 0 will be applied to the first row since there is no prior row to reference. When we display the result using the show method, the first row Bob with the lowest salary of 4,500 has a previous underscore salary value of 0 because there is no row before it. For subsequent rows, the previous underscore salary column contains the salary from the preceding row. For example, Charlie has a salary of 6,000 and the previous underscore salary for Charlie is 4,500, which comes from Bob's salary. This example demonstrates how to use the lag function with a default value to handle cases where no previous row exists. This is useful for avoiding null values and ensuring that every row has a meaningful value for comparison, even at the start of a sequence. That wraps up our tutorial on the PySpark SQL-like function. I hope you now have a solid understanding of how to use this function to access previous rows and perform insightful data comparisons. If you enjoyed the video or found it helpful, don't forget to like, subscribe, and hit the notification bell to stay updated with more PySpark tutorials. Thanks for watching and see you in the next video.